Hello everybody and welcome to another ATC Maths and Science tutorial video. Today we'll be looking at the topic rate of change. So firstly, let's discuss the term itself, rate of change. What does it mean? Now, rate of change in physics, whenever we deal with it, it means something divided by time. Now, translating that to mathematics, it tells us that whatever equation we're going to be looking at is going to have t as the variable because it's something with respects to time. Now, the way we approach this question is going to involve what I like to call word association, which means within the question itself, when we see a particular word or phrase, it tells us exactly what we're supposed to do to solve this problem. So before we attempt this particular question, right, let us learn what those words are that we're looking for, so that we can then approach this particular question that I had on screen previously, which was from November 2016, question 10, the November final exams. Right. So before we deal with that, let us look at what are those terms, what are the words that we're looking for, right? So we're dealing with the section rate of change. Now, there are just three key words that we will notice somewhere along the line within the story, within the question, because as I'm sure you would realize, having looked at many rate of change questions, the question is in the form of a story. So it will say, as in that question 10, is like the certain molecules of a particular drug in the bloodstream is, and then they'll give us a formula that represents it. So this is what we're expected to know. Firstly, whenever we see the word initial or a synonym of that word, like start or beginning, this implies that t, time, is equal to 0. So that's the first word. It's like a key word. So as we read through the question, the moment we see this particular key word, it tells us into the equation, we've got to substitute time being 0. The second key word is actually from the title itself of the section, which is rate of change. Now, whenever we see the phrase rate of change or rate of, this means derivative, which tells us that we've got to find the derivative. What we do with the derivative after we've found it, that will be described to us later on within the question or as part of the question itself. But whenever we see the word rate of, this means we have to find the derivative. The third and final thing we need to look for is the words maximum or minimum. This tells us that we need to set the derivative equal to 0. Now, this question in the section rate of change is one that we must be very careful of, because if you notice, I said we must find the derivative and set it equal to 0. I did not say which derivative. Is it the first derivative, f prime, or is it the second derivative, f double prime? The question again itself will tell us whether we need the first or second derivative. So if we see the word maximum or minimum in the question, then we need to do one of two things. We find f prime of t and set it equal to 0, the first derivative, or we will find f double prime of t and set that equal to 0, and in both cases then solve for t. So that's the three key words that we will discover as we look through a question. Let's take this concept and apply it to our previous question that we had. Right? Remember that again was from November 2016. So if we look through this question, let's read through this, and remember we're looking for the words initial, maximum, minimum, and rate of change, right? And we'll highlight it as we go along. The number of molecules of a certain drug in the bloodstream t hours after it has been taken is represented by the equation m of t is equal to minus t cubed plus 3t squared plus 72t, where t will be a value between 0 and 10 hours, which means that it's to understand that why they gave us this inequality. Any medication that you take, it doesn't last in your bloodstream or stay in your body forever. It's going to have a maximum time frame. So it's after 10 hours, it's not present in your bloodstream anymore, right? So going on to 10.1, it says, determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. Now, when we read through this, as we read through this question, you'll notice that neither of the, or none of the three terms that we're looking for is present in here. And it's just asking us to find number of molecules, which is represented by this equation. We know that M, as it says here, number of molecules of a certain drug, that's M. So we would say to ourselves, okay, 10.1. We just want to find M of 3, which is equal to minus 3t, or well, substituting 3 in here, so 3 cubed plus 3 times 3 squared plus 72 times 3, which gives me negative 27 plus 27 plus 216. And this would give us a final answer of 216 molecules. So that's 10.1. Now again, as we read through 10.2, we're looking for these keywords. Determine the, and there's the first one, rate at which the number of molecules of the drug in the bloodstream is changing at exactly 2 hours after the drug was taken. So we see the word rate, rate at which, or rate of. This means that we're not going to be working with this equation, but rather its derivative. So we need to find m prime of t. So m prime of t would be equal to negative 3t squared plus 6t plus 72. And they want to know this value when t is equal to 2. And this would then give us negative 12 plus 12 plus 72, which is 72 molecules per hour. Now, there were a few students over the years who always wanted to know, how do I know what the units should be? Why was the first question's units molecules, whereas the second one is molecules per hour? Now remember, understanding that in 10.1 the units was molecules is because that's the formula that I'm using, M, number of molecules. How do I know that the derivative will be number of molecules per hour? The units will always be whatever was the units for the original equation divided by the units for time. And so that's how I would have decided that it's molecules per hour. Right? So that's 10.2. From here we go on to 10.3. And it says, how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream is changing be A? And there's our next keyword, maximum. So this means derivative equal to 0. Now we have to ask ourselves the question, which derivative? Is it the first derivative or the second derivative? Let's look at the rest of the question. So it says, how many hours after taking the drug will the rate be a maximum? The rate is going to be a maximum. So it's not the number of molecules, which is m, that must be a maximum. It is the rate that must be a maximum. Therefore, we are referring to not the first, but the second derivative. So 10.3 m double prime of t is equal to minus 6t plus 6. We set this equal to 0 and solve for t. Therefore, t is equal to 1 hour. And that is how we deal with the section rate of change. However, is there anything further that we need to discuss about rate of change? Well, there is one more point that we need to know about rate of change, and that has to do with distance, speed, and time. Now, normally, whenever we're talking about a question that involves rate of change, you must see the words rate of. One of the questions must have it. I mean, that's the title of the section. However, there is this three things that we are looking at. So distance, speed, and time, or rather displacement, which is an alternate word for distance. So displacement, which we use the variable s to talk about. Speed or velocity, which we use the symbol v to describe. And then time and acceleration, which is a. Now, we're expected to know the following. We're expected to know that velocity is the rate of change of displacement. So again, so we're doing that word association. Rate of change, the rate of change of displacement, that means that velocity must be equal to the derivative of displacement. We're also expected to know that acceleration's definition is the rate of change of velocity, which means that acceleration must be the derivative of velocity, which makes it the second derivative of displacement. And this is the only extra knowledge, like very specific. This theory is very specific to questions that give us information about displacement, velocity, acceleration, and time. And with that, that is the conclusion to all that you need to know, the basic theory for the section, rate of change.